Earlier we produced a video on end grain turning, and we showed you how many of the tools cut. Reference for that is down below here in the comments. I want to take that to another level, and we're going to do end grain hollowing, but inside of a hollow vessel, an area we've not ever done before. And what we're planning on doing is 3 videos. This one will be a small one using carbide hollowing tools. We'll do another one which will be a larger vessel, and we'll use an entirely different set of tools for that video. And the last in this series is going to show you how stabilized hollowing systems work. Many on the market, they all have many similar characteristics, and we'll show you the one that I use at home. I don't know what this is. It's a piece of pretty irregular wood, but this is what I'm going to make the project out of. So my first job will be to trim this up, cut it to an appropriate length for this small project, and get ready to start turning. So I'm going to go to the bandsaw, process this piece of wood. I'll be back in a couple of minutes. Okay. Okay. So I cut the blank short. This much is going to be tenon on one end. This is going to be the vessel. I said it's going to be a small vessel, so it's not very big. And the tools, which you'll see pictures of, are really for small format work. And that's what we're going to do. So the first thing to do is get this round, get a tenon on one end, get it into our 4-jaw chuck, and then shape out the project and begin to do the hollowing. So first thing to do is round it out and get a tenon on, which I'll do right now. So we continue to have a little bit of tear out, as you can see, down here. So I'm going to make this the tenon end. This seems to be more solid here, so I'm going to use this end for the project. So I'm going to put a tenon on it. Generally, I put the tenon on that end because it's easier to get to work, but I'm going to do it here because that's where I want it. It's a nice solid tenon. We'll be in good shape. So let's get rid of the spur drive and install a 4-jaw chuck. Still have an alignment mark here that helps get this centered properly. Mark here helps. I like to use that pin to help hold it, but it also helps me get it properly centered. I like to use that And I keep help hold it, tightening as long as it'll move. It's centered. And I keep tightening. We'll go back and retrue just to see that we're in good shape. It's moved a little bit, not much. So now it's create the shape. Moved a little bit. So that's roughly where it's going to be. I'm going to take this base in more, but later. I need all the support I can get right now. And what I want to do is take this out of the tailstock. And that's simply so I don't hang myself up on it. I have marks from that in the past. Let's clean up the top edge. Okay, so we have a rough vessel, and the next thing, remember this is end grain hollowing. And so for end grain, we have to move from the center out towards the outside, which means I have to have a pilot hole in here first. I'm going to drill a hole in here. And I'm going to use this drill bit. If I want a larger hole, I'll go to a larger bit, but I'll start off with a smaller one. These are Morris taper shanked drill bits, which means they're cut directly in the tailstock, which is really nice and convenient. And that's going to be right at center, drilling at much lower speed. I don't know what that speed is, but it's probably around 500. We don't have a digital readout on this machine, so I'm not sure for sure. So that I want to go about that far, which is up to here. And you can see the fibers swell, means there's always a certain amount of residual moisture in the wood. So as you drill, it creates heat, drives the moisture out, fibers swell. If it's a big hole, deep hole, I would have taken several passes. I'm extracting that drill bit. I'm going to install the larger one. Same thing, just make the hole bigger. We have a hole down to about here, and now I can begin to do that hollowing from the center out. And that means I'm going to have to use a tool that's designed for that particular purpose, and that is a hollowing tool. We have pictures of these. This is a set of carbide hollowing tools designed for small work. There's a straight one, which will take the majority of the mass out. And there's a curved one, which will get back under corners and curves a little bit and bring in the shape right into here. There are other small tools. This is a miniature Kel-McNaughton set, which is also designed for the same purpose. This is high-speed steel fused to a solid tool steel background. So I can use either one of these to do that. But I need to be right on center line. And since these two tools are different diameters, center line is a little bit different, so I've got to find exactly where center is. There it is. Find an appropriate handle for it. I'm trying to figure out how long I want that piece to stick out. Keep that here. And what I'm going to be doing now is going in here. Now I don't want the tool straight. I've lined up the cutter with the screws so I know where it is when I can't see it. But I'm going to roll it about 30 to 40 degrees counterclockwise. And I can come in here and make cuts like this. Don't know the wood? Let's see how it cuts. Pick up some speed. So here's straight in. Tool's invisible. But I want to roll. Carbide tools were originally brought into wood turning for jobs just like this. Hollowing, we've been using them for a long time. Recently, carbide tools have been adapted for spindle and long grain work rather than just for end grain work, and that's fairly recent. What I need to do, rather than use my fingers, is I need to have a pair of calipers so I can check this as I go. So I'm going to bring out a pair of calipers that is appropriate for this kind of work. I went into the shop and pulled out a set of calipers that are designed specifically for working with hollow vessels. These are made by Mike Tchaikovsky and are available in multiple sizes. But I can come in here and tell what the wall thickness is at any place. And you can see right now the wall thickness is about 3/16 right here, getting thicker up here. And depending on what the project is, sometimes you can go in this way, all sorts of different directions, but these are really handy. Well, that tool's worked pretty good. Let's try a different tool, just for the fun of it. These are the miniature McNaughton tools. I'm just changing it into the same handle. Again, lining up the flat of the tool with the screws on top so that when we're hidden in here, I can tell right where I am. Let's see how this cuts. We're going to clean up this area here. Also hold it with the hand on the bottom. Now I have a very large hole. As a result, I could do an awful lot with a straight tool. With a smaller hole, I'd have to have something that has some shape to it in order to get in and around those corners. But this is a fairly big hole. Now I'm down to where I've not cut before. I can tell that I'm at that spot because I have smoothed it from here up to about here. And if you were able to put your finger in here, like I can, you'll find that there's a shoulder right there. So when I put the tool in, I come down, I hit that shoulder, and I know exactly where I left off. So now I need to take the next step down. I always leave a shoulder as I hollow down. The idea of that is I always know where the tool needs to go back. There's my shoulder. And I'm going to go from the center out. I'm pulling out in an arc like this. Now I'm going to go in from the top this direction right into the end grain simply to smooth. thing about end grain hollowing, with the tools that you use and the experience you develop, you'll begin to recognize by feel of the tool, what's going on inside. I can tell that down to about here, I'm pretty well done. I need another tool. Everybody who does hollowing has one of these. It's just a piece of aluminum rod that I flattened out one end. Always got to get the chips out. If you have air pressure in your shop, that's okay, but that blows stuff around a lot. The other thing about this, I can feel the wall as I do it. I know there's the shoulder, there's the curve. I'm right at that spot right there. Can I tell where that is? It's right there. So I use it as a measuring tool as well. So let's check the wall just so we can. That's about right, 3/16. And as we come down, there's where the shoulder is. So, what else can I do? This is a tool that comes from Doug Thompson. Another set of miniature hollowing tools. Another carbide tipped tool. And for hollowing, the ones that work best are these that have the round shaft. By having a round shaft, what that means is that I can roll the tool at any angle I choose. Let me loosen the screws just a little bit more. I don't need it very long. And I'm going to keep it, again, lined with the screws. And so when I roll it over, I can change the angle. But also look what else Doug Thompson has done. He's put this at a beveled angle in the first place. So it's a shearing cut even if I go in straight. If I do it this way, it's a shearing cut on two planes, this plane and this plane. So let's see how it cuts. This is fun, just practicing and playing with different tools and getting the feel for the one that feels best to me. That's the part I've already done, I'm just checking it. I don't know if you can hear it, but the sound is really a different sound, very clean sound. The other thing that happens as you turn, the chips begin to interfere with the ability to cut. So you have to keep clean. Now, that tool has left a very, very nice surface right here at the beginning because I can feel it with the spoon. So I'll go here at the top of the vessel, slide down the side. I'm going to try to hold it so you can see better. That's about where I am now, down about here. This wood I thought was dry. As I'm cutting it, I find there's still some moisture reserves in it. And as I feel the chips, I can feel coolness in the chips, which means that it's releasing some moisture. So it wasn't as dry as I thought it was. There's the shoulder. You watch me carefully pull the tool out. If I was working through a very small hole and I didn't pull that out carefully, I might have changed the size of the opening substantially. Okay, let's see where we are. Always fun to check. We know that. That's about the same. And right there's where it's getting thick. So I know where I am. See what else I got to work with. Here's a set of tools that I made a few years ago. I shaped the shaft. We bought the round carbide cutters and screws and made our own. So let's see how they cut. I think when you buy tools for jobs like this, you find one that suits you. I like round shafts rather than rectangular shafts. Here's one with a rectangular shaft. The angle's fine, but I can't roll it very well, so it doesn't work quite as well for this particular job. So I'm probably not going to use that tool. But let's try my straight cutter. Smaller cutter, smaller diameter shaft means that the farther this one hangs into the vessel, the more likely it is to develop some chatter. So bigger shafts for deeper holes. The farther down you go, the bigger the tool needs to be in order to be quiet while it cuts. I'm going to follow down the side. There's the shoulder right there. So I'm going to go into the center hole, cut from the center towards the outside. That's interesting. Now I am sitting here with my hand on top of the tool, and I know that hides your ability to be able to see things. But I feel so much more comfortable holding it down on the tool rest than supporting it from the bottom. And I'll try to do a cut like this every now and then. Well, my tools work. But I'll tell you already that they don't work as well as the professional tools. I can tell the cut is different and it's less efficient. So I'm feeling the inside of the hole again. So there's the bottom. There's the shoulder right there. So let's measure where that is. It's down here. We haven't moved down very far. I could use this tool, the square one, because I have a very large hole through which I can work. And that would work. But I'm happy with the commercial tools that I have been using. What else do I have? It's always fun to keep playing. Here's another one. This is just like this tool, except the shaft is almost twice the diameter. The difference is that this one should be able to reach much further into a vessel than the other one, simply because it is bigger in diameter. So it doesn't fit that handle. I'll have to fit it into my hole gouge handle. Again, lining up the screws. One thing about the handles, the longer they are, the more arm support you have with it. Now, bigger tool. This is above center line. I'm going to have to drop my tool rest a little bit. And that puts the tool in center line. Screws where I want it. Speed's okay. I'm going to try to hold this in the bottom so you can see that. And down the side. There's the shoulder. So I'm going into the center of the hole, pulling toward me to enlarge that hole. lot of time looking down here. I can't see anything any better than you can. It's just habit. So I might as well look at the camera because I can see every bit as well as when I look down at the project. There's the bottom. Now I need to smooth that area towards the bottom out a little bit better. And to go with the flow of the grain, I need to cut from the center out towards the edge. And every now and then, clean up our chips. There's the bottom. Now there's a bump right there. Right there, there's a bump. So I need to make the bump go away. So that's right there. I got my tool at the bump. I'm holding it against the rest so that when I go in here, there's the bump right there. Now it stopped cutting. And it stopped cutting because it's running into the chips. The chips pile up the most right there because that is the largest diameter and they'll move to that area. So when I'm trying to cut in that area, the chips then many times interfere. Again, a cleanup cut. Let's go from the bottom out. Roll. That bump again. It feels pretty good, but you never can tell. So let's do a field test. So from the bottom, the side is smooth. Right at the bottom, in the center, I need to pull right here, because if I stared down in that hole, I would see the bottom is not perfectly round. So one more cut at the bottom, one more cut. And go straight into the center. Around that bottom a little bit. And let's see if we got it. Feels pretty good. So now I need to work on the outside again. I intended to bring this bottom in. I left it large because that allowed me to be able to have the most amount of stability I possibly can. And to finish this off, I need to go back to my gouge, my bowl gouge again. So I'll take this tool back out, put my double-ended bowl gouge in. I use this end. I sharpen both, so I'm going to put the sharper end in just simply to clean up. And check the height. For that gouge, it's still high. This tool safely out of the way. And what I'm going to do is simply work on the shape just a little bit. I want to have a little more curve here. This needs to come in a lot. So I'll take care of this end first. tight. So let's check where the bottom is again. The bottom is right there, so this is just exactly where I should curve that in and pull it in. Just about right. Create a little more clearance. Parting tool. So at this point, sandpaper time. And from sandpaper, I can go to whatever kind of finish I want to do. I put the parting cut here because I wanted to establish exactly where the bottom of the bottom was. And you saw me come back with my bowl gouge and take one last cut here. There's always sometimes a little finish to the bottom edge that I don't see until I put that parting cut in. I'm not going to take it any farther because I want to be able to leave it in the chuck while I sand and finish it. And then I'll part this off here. So today I just wanted to show you some of the smaller tools that can be used for hollowing, specifically for smaller projects. And these carbide tools work really, really well. The other ones that are available are the McNaughtons, which I don't see laying here anymore. I thought I had them right here. But the McNaughton is simply a tool like this. It comes in different shapes. This is the smallest of the sets. There are 4 or 5 different sizes depending on the size of the project. So I hope this helped you look at doing small projects, small hollowing projects, drilling a hole, hollowing it out, using an appropriate set of small carbide tools. Next video we're going to do is I'm going to do something much larger, and instead of hollowing from this direction, I'm going to hollow it from the bottom. Come back and see us in the next video. Hope this is good for you and you're learning stuff. If you are, please subscribe and give us a thumbs up. We appreciate it. We'll see you in the next video.